I'm here with Richard at ORCA Computing, a techUK member company, to find out more about what they do and how they're leading on innovation in the UK. So firstly, Richard, thank you for inviting us here to your facilities.
Yeah, thanks for coming.
So first questions first, what does ORCA Computing do?
So ORCA Computing, we're still quite a new company. We were formed in 2019. We're just under 50 employees based in London. Our business is mostly relating to building quantum computers, in particular building quantum computers out of single photons, so what's known as photonic quantum computing. And when you see later, when we go and have a look, our quantum computers look quite different from what people expect quantum computers to look like. They're rack mounted, there's no cryogenic cooling, there's no golden chandelier, which is what most people think of when they think of a quantum computer. So we believe in making quantum computing a lot more accessible to people trying to find out how to use it and get into the space. The second part of ORCA is relating to the application. So we're actually about 50% software, so 50% hardware, 50% software. And so we also work a lot on the application of quantum computing, both in the short term and long term. And specifically in the short term, we really believe that there are a lot of exciting applications relating to applying quantum computing to machine learning and generative modeling. So we work with different customers, different users of classical machine learning and high performance computing to help them understand what, if they incorporate quantum computing into what they're doing today, can that be any better? Can it help improve some of the machine learning models they're already running? And it's quite exciting working with customers like that in that type of space.
Yeah, I can imagine. And so you talk about working with others. I mean, where do you sit in the UK's innovation ecosystem? Who do you work most closely with?
It's a good question. I always describe ORCA as sort of sitting specifically in the middle. So I don't like us building a lot of advanced components. So we try not to manufacture things. We try and incorporate novel telecoms components, or photonic components and things like that. And we also try not to be highly application orientated. So we also believe it's not our job to be the ones who are working on specifically applying quantum computers to specific problems within specific industries. But there's a big middle ground there. So what we do is assemble different components from different suppliers from UK and globally together into a system and then work on sort of the low-level frameworks, if you like, low-level algorithms, which then support users trying to apply those sort of new types of software and solutions to their end applications. So we're sort of middle player. I mean, people describe us as a sort of systems integrator type company, but what that means is we rely on a lot of collaboration within the ecosystem. I mean, one of our philosophies is it's so hard. I mean, what we're trying to do is redefine how people approach computing. It's sort of simple as that, or as grand as that. That's quite a big job to do. And if you try and do everything yourself, you become distracted in many different ways. So rather than do everything ourselves, we pick one, in our view, sort of the hardest thing to do in the middle. And then we collaborate with different users and different companies on both ends of the spectrum. And to give some more concrete illustrations, I can't name the specific companies, but we work with very large energy customers, for example. So our job is to sort of provide the hardware and provide a software environment for that large energy company to understand how quantum computing can relate to many different areas of their business, how quantum computing can be used to maybe optimize the placement of wind farms, for example, or optimize sort of large logistical networks within that company, for example. So we sort of seed their interest with a few different software platforms, but ultimately we're guided by their end user applications, and we sort of work together to achieve that connection, that understanding of where quantum computing can be really applied. And maybe that's the last thing to say is quantum computing is so vast. It is, the next generation. It's a new form of computing altogether as we know it. So it really requires to be very specific on where you want to apply it. So don't try and apply it to everything, but specifically where do you want to apply it to find the applications which both make the most difference to that end customer and also to be possible in the least amount of time, be unlocked the soonest, if that makes sense.
Yeah, it does, absolutely. Well, you've mentioned that your quantum computer doesn't quite look like what we would assume one to look like. Are we able to have a look at one?
Yeah, absolutely. There's several in the lab being assembled actually for our next customer, so we can go and have a look and see what's going on in the assembly area we have. When we go in there, you'll see, as I said, it doesn't look anything like what people imagine a quantum computer to look like. Essentially, we build systems from existing telecoms networks. So because we use light, because we use single photons, we can build quantum computers out of what is essentially networking equipment. So inside the box, I don't know if you'll see it, but inside the box is a lot of optical fiber, a lot of telecom switches. These are all really mature components which we can integrate into these boxes without cryogenic cooling or anything else like that, and really allows us to, as you'll see, build these systems into boxes, rack-mounted boxes, which is how the industry like to work with computing systems.
Yeah, absolutely. Well, let's go and take a look.
Great, sounds good. What this system does, it sits side by side with a classical computer and can be used to help replace or add to an existing classical neural network to help the overall machine learning model or whatever you're working with just work better, more efficiently or more accurately or something like that.
Okay.
Yeah, if that makes sense.
I think it does.
The basics of quantum computing in 10 seconds.
Yeah, brilliant. And so, when you take this computer and you scale up its impact across the UK's economy, what is your vision for that impact? Where do you see ORCA changing things in substantial ways in the future?
Yeah, so quantum computing is really early. So we're looking at really the dawn of a new type of computing, and people should sort of see it like that. What you're looking at is a technology that over the next 10, 15, 50 years will completely change the way people interact with computers. So our vision is that right now what we want to do is engage with customers to find those first use cases, but ultimately watch as industry transitions across to hybrid quantum classical and then potentially for some things fully quantum computing. And what that'll do is open up areas of computing that today people just don't think are possible. Yeah. So the end dream of quantum computing is that it really allows you to do things that people don't even consider possible right now with current computing systems, like much more effective design of new materials, new drugs, much more efficient optimization, much more maybe sort of natural artificial intelligence, really advanced computing and just really expanding what people think is possible with current computing.
That's such an exciting vision and prospect, I think.
Yeah, and it is a long-term journey. We believe in doing things as quickly as we can with customers and seeing what's out there. But what's really exciting, the reason why many companies engage with us is they're in it for the long term. They're in it to make sure they're not caught out by this completely new computing paradigm. As it slowly evolves and becomes more and more impactful on everything they're trying to do. And so, it's not often that you're able to take a whole area of physics, really, and watch it being industrialized and commercialized. The final part about things which really excites me is, it's been an area of academic research of physics for decades now. Yeah. And it's only now that, as a company, we're able to take all of that physics and commercialize it. So that means putting it in a nice looking box, but it also means deploying it to customers, providing services and software and things like that to really make quantum computing less of a research theme and more of a new industry. So it really does feel like the dawn of a completely new industry. And by the way, one in which the UK is really leading. The UK is really advanced worldwide in terms of what we're doing.
Yeah, I can imagine. And so you talk about commercialization of your technology. Your techUK members, we have a huge quantum program and emerging technologies program at techUK. So can you tell me a bit about how you work with or through techUK to make this a reality? Yeah,
so I guess there are two reasons for our interest and our participation with techUK. One is to connect as much as we can with the UK tech ecosystem, because the technology is sort of disruptive, but also is hard to accommodate and incorporate as quantum. We really want to be working in this collaborative environment with the whole UK ecosystem. And to be honest, as a small company, it's hard to have that reach to make sure people are aware of what we're doing, but also that we're aware of what other people are doing throughout the whole UK ecosystem. And techUK really helps bring us together with small and large companies throughout the UK to help do that. I think the second is also to reflect that this is a major area of government investment, and again, it's important that we stay up to date with what government are thinking and that we also provide our thoughts into government. That's hard to do as a small company. We get very distracted by the things that matter, building the product and things. And it's nice and important for us to be able to rely on techUK to give us that reach into government that for a company our size that we wouldn't have without our interactions with techUK, if that makes sense.
Absolutely, yeah. Well, I'm very happy that techUK is really benefiting your company, helping you commercialise this.
And it's great, and the focus that techUK have had in quantum, there have been a number of reports where techUK have provided input into government, for example, is fantastic for us to have and really useful as a company.
Amazing. Well, Richard, thanks again for inviting us here, and we'll continue to work together in the future.
No problem. Yeah, thanks. Cheers.